Hey, um, welcome to part 2 of the SIGTYP presentation. If you fell straight from to here from something like YouTube, this presentation is mostly independent of the first part. So you can start from here if you want. But yeah, so I'll present now this second paper, which is called Disambiguatory Signals Are Stronger in Word Initial Positions. And this is, again, joint work with Brian Cottrell and Brian Rohr. So the research question we were looking into when working on this is if word initial segments are more informative for disambiguation than word final ones. So in other words, is it easier to guess the ending of dino or the prefix of sar? So basically what we want to know is if the first half of the word is more informative for you to disambiguate the full words or the second half. And there is a lot of prior psycholinguistics work on this topic. And basically what most of them conclude is that the first half is more important for human disambiguation or lexical retrieval than the second halves. But while interesting, these results do not tell us exactly what we specifically want to know. They tell us how useful these segments are for humans. But what we want to know here is how informative these segments are in the abstract. So we have to come up with another way of measuring it. And the most straightforward way of doing this would be to use the segment's contextual entropy as a measure of information. This is a kind of the go-to metric in information-theoretical linguistics. You just take the surprisal of each character in context, and the context here can be just like the word itself. So given the previous characters in the word. So what this equation is measuring is the entropy of a character given the previous characters in the same word. The problem with doing this is that there's an inherent confound here between the size of the context you're given the metric and the position of a character in the word. And just FYI, a few prior work has looked into using this metric to answer this question. But the problem is that conditioning information can only reduce entropy. This is kind of a law or a rule in information theory. And using then this contextual entropy going forward in the string always confounds the amount of conditional information you have at each position with the position itself. So as an example, consider an artificial language where every word contains a copy of its first half. So you would have words like fufu, barbar, and fubar, fubar. The initial and the final halves of these words have identical disambiguatory power, because by design in this language, they are the same, right? But the conditional surprisal would be nearly zero for the final halves. And this shows how these two things do not measure the same thing. Conditional surprisal does not measure what we want. So this begs the question of if this left to right conditional entropy measures a property of the lexicon or simply the fact that conditioning reduces entropy. And when we say left to right here, we're talking about like on time. So if you have a language like Arabic, you would actually be doing right to left. So to evaluate the size of this issue, we first gotten the the average surprisal for the first halves of the words and the final halves of words using this forward surprisal metric. And we got the number of languages in which the initial half is significantly higher than the final half on average. And here are the results. And you can see that in basically all the analyzed languages, the word initial segments are more informative than the word final ones. And here is a plot of the same results. You can see they are very far below the identity line, showing this is a very strong result. But the figure changes quite a lot when we look instead at a backward surprisal. So if we go backwards in the words, in this case, we see that a lot of the languages actually have a larger word final surprisals, showing how these metrics are confounding what they want to measure with the position of the characters and how they are biased in the sense. So by putting the figures side by side, we can see clearly that there is a large effect of the amount of conditional information in this analysis. But there is also some lexical effect that seems to be going on in here, but it's hard to disentangle what is actually going on by just looking at these metrics alone. So what we propose in this paper is to use 3 different measures that control for context size. So independent of the word position you're looking at, the context size will be the same. And these measures will be the unigram surprisal, which measures the full information a segment conveys. The closed surprisal, which measures the amount of non-redundant information a segment conveys. So how much information a segment conveys, given that you know all other segments in the same word. And finally, the what we call the position-specific surprisal, which is the amount of information a segment conveys when you're primed by the position and the length of the word, the position of that segment and the length of the word. So, and this is inspired by this experiment by Nootboom and van der Vlugt, which we'll go into later when we're discussing the results. So we use 3 data sets for our analysis: SELEX, NorFerLex, Wikipedia, and the NorFerLex I talked about on part 1. But these data sets cover a very different number of languages, and they also differ a lot in the diversity of the samples. And more importantly, in SELEX, we can analyze only monomorphemic words because it has morpheme annotation. NorFerLex, as I said before, has concept-aligned word lists and only has basic concepts. So in some sense, it kind of controls for morphology, even though it does not control directly for it. And in Wikipedia, we have no morphology control. So we'll have all kind of morphological composition going on in the word list. And Wikipedia has graphemes. It uses orthography, while NorFerLex and SELEX will have phoneme. So the words will be all annotated in IPA. So looking at the results, we can see that there seems to be a cross-linguistic tendency to front-load disambiguatory information with all the 3 metrics we propose. But we also see that this is not a universal phenomena, as was believed before, and that some languages even have more informative word final segments, which was surprising. We can see this again in this plot, where all the dots, all the languages are much closer to the identity line than they were in the forward surprisal experiment. Looking more closely at the results, we see that when we control for morphology, only roughly half the languages have larger word initial surprisal when we use close surprisal, which is also interesting. And when we look at the position-specific surprisals, we see that these are the weakest results in terms of the least amount of languages with strongest word initial surprisal. And this was especially interesting since prior work investigating how easy it was to recover lexical items from beginnings or endings has found that it's easier to recover words from their beginnings. This was the result in this notebook paper. But in a follow-up paper, they found that this difference vanishes when people are primed with the length of the word, which is very related to how we built this model, which we give the information of word length and word position before taking the surprises. So we found that that was pretty interesting. And this is it for part 2. And I'll see you in part 3. See you.